Okay, investigation 10.2. Again, you're going to be using the atom board for this one. I believe this is the last one that will use this. But this one is more focused on energy levels, so how electrons can move up and down energy levels, and when they do that, how they emit light. So before jumping into this, you may want to give some examples like neon lights. That might be how they work. You add in electricity, it bumps our electrons up, and then when they jump back down, they emit a specific color of light. You also could find some good videos or other materials that might follow this. I believe in your light and optics kit, I do know there is a little patch in there that's a glow in the dark patch. I think, I'm gonna have to double check myself, I think that's how those work, is as they're exposed to light, it's pushing electrons up into higher orbitals, and then after the light goes out, those electrons jumping back down emits the light that lets them glow for longer periods of time. So try to give your students some real world application before jumping into this. Also, this would be a great lab for chemistry students when you get to that part of the lab. But essentially have this set up first with a neon atom, so 10, 10, 10 of each one, and then pull out of, you want to grab your photons and laser, this is in the kit, the little cards, and pull out of there. It tells you in the instructions, one red card that says pump, one red card that says laser, and a yellow that says pump. And so what pump means is that's adding energy onto my atom here. So it says, so it asks a couple questions. I think I got to turn the page. All right, so take the pump red card and put it on the atom board. So I've added in one energy level. So I'm gonna go ahead and bump from the second level, he's gonna get bumped up. So now there is an empty space here. Remember, the electrons want to be at the lowest state possible, but there's only so many spots that can be filled there. Then I'm gonna play, it tells me to play the pump 2 card. So now I might be able to bump up this one and this one. So my electrons, now I've got 3 open spaces. And then I'm gonna play my laser card. Laser is gonna bring one of those down, and that's how light would get emitted from that jump down. So energy is put in to move them up. So when the electron does jump down a level, it has to give away energy, and that's where the light comes off. That's why I wanted to give real world examples, so this isn't just some weird abstract game. Students know what's going on in the real world. Okay? So once students have done this, there's questions that go with all that. There's actually a game starting in section 3 for them to play, and it's using this deck of cards. So I'll briefly talk about it, but it's there. Each player will get 5 cards, and the way you score points is by your, wow, I need to shuffle this more. I got all of those. So make sure you shuffle this up pretty well. But the way it works is students can play either pump cards to move the electrons up. You don't get any points for that, but you do get to discard that card and draw a new one. But when you play a laser card, you get a point for however many electrons jump down a level. And you're trying to score a certain amount of points, I'm sure. Or you just play until the cards are out, but just have a set number of turns or a timer. But that's how you would earn points. So pretty basic. I wouldn't have students playing that for very long, but it does have them do some follow-up questions after they've played that game. It's helping them understand what ground state is, which is the lowest possible. And then as energy comes in and you bump things up, now we're at a heightened state. That energy has to be emitted through light. So pretty fun. Kind of look into that. Maybe change the rules to modify for your own students, but the last bit of it also asks you to get out a spectrometer. I don't think these come with the CPO kits. I looked around, but most schools will have some of these. And you got 2 sides. One side is a slit, and the other side has your eye hole. And why you want to do this is pretty much for every school, you've got the fluorescent lights. Fluorescents are going to be made with gases getting electrified. And this process here is what's giving off that light. And so if students actually look into one end, I've got to take glasses off, but they look into one of those, they should see off to the side. So it's just going to be bright in the middle, tell them to ignore that. But if they look off to the side, they're gonna see a rainbow of colors. And so that can be used to determine what type of gas is in that light bulb. I think when you've got a ton of colors, you're probably looking at a mixture, so that way you get the white light. But if you're able to get fluorescent lights of different colors, you could actually identify which gas is in there. So if you're lucky enough to have that at your school, you could totally do that experiment with these. It's a pretty simple device, and you probably have some lying around. All right, well that ends investigation 10.2, and I believe we are done with the boards. The last investigation is just gonna require a bunch of pennies. So I will see you guys in that next video. Bye.